Hey everyone, and welcome back to the channel Question Code. Today we'll deep dive into one of very important framework of agentic AI, that is LangGraph. Previously, I've covered ClearAI, I've covered OpenAI Agentic AI, then we have Microsoft Autogen. Today we'll deep dive into LangGraph. LangGraph is basically most like uh, used agentic AI framework till now. So you might have heard of LangChain. LangChain is very great for sequential operation, but when you need dynamic decisions, making conditional logic, and the ability to loop back into outcomes, simple chains they basically just fall short. So with LangGraph, we get multiple features. I'll cover one of by like all the important core concept of LangGraph first. So LangGraph is developed by uh, developed after LangChain only. And why LangGraph is better than other agentic AI frameworks? Because it is stateful by design. So stateful means it manages the present state that flows through the graph. So it is very critical for conversational memory and multi-step reasoning. So let's suppose you are talking to LLM and you are asking one task to complete it. Let's suppose you are asking LLM that plan a trip to Paris. So it might not in future chats it might not remember your previous chat. So in that way it is very important, like this is statefulness of this LangGraph. uh, in LangGraph we have graph based control. So this gives you explicit control over the flow of your agent. So it allow you very complex loops. Let's suppose you are in your loop, you are asking LLM to call one tool and again come back to LLM to think about it. So these things you can easily create with LangGraph. Then for observability, we have Langsmith also with LangGraph. You can visualize your agent decision making process and execution path, everything you can easily visualize. And we have flexibility into LangGraph. So each node can be LLM call, a tool invocation. In each of every node, you can call to a different LLM. And also in LangGraph, we have asynchronous support. So it's built for modern responsive application. So it supports the asynchronous operation for better performance. So these are the features why LangGraph is very popular agentic AI framework. And in LangGraph, basically we have some core components. Let's cover these core components also here. First, we have state. So state is basically single source of truth that defines the current state of your agent. So current state means if what message it is containing. It's a, if it is a Python dictionary like object that passed into one node to another. Think of state as like agent short-term memory. Then we have nodes. Nodes are basically individual steps for unit of your graph. A node can be LLM call, a node can be your tool call, or any custom Python function, anything node can be. Then we have edges. So you can think of like this. So it is our start of graph. Then we have, let's suppose, LLM. Then uh, you might have one tool, then it is ending this graph. So these start LLM tool and these are the nodes, and process by which it goes from start to LLM and LLM to tool, tool to end. This process is basically edges. So these edges defines the transactions between nodes. So like they dictate what will be the flow of execution. There might be direct edges also like this, and there might be conditional edges where we give any condition, like this tool will be called, let's suppose there is one tool for calculation, so that will be called if there is any instruction for calculation, so that conditional tool call can also be there. Then we have graph. So graph is, I have already explained you, like this is the overall structure that connects node and edges and manages the state of this chat. All right, here we are in our Jupyter notebook. I've got a fresh notebook, fresh cell open. We'll start and progressively build up a more sophisticated agent chatbot. We'll try to build up here. So for that, we need some inputs first. So first is from langgraph.graph, we need import state graph, start and end. So I'm using cursor ID. You can also use this. So this is very helpful when you are building any agentic AI application. And then we need to import one message, add message also. Add message, and we need annotate and typed it also. This is for typing from fields with metadata. From typing, import typed it, and from typing we will import the annotated also. Let's run this, execute it. You might need to install LangGraph into your system first. I have already installed it, so you can basically just pip install LangGraph. Next we'll define the state of our chatbot. So remember how I mentioned state is very crucial for this chatbot. So we need to define one class. In that class, basically we need to define one this state, and we'll pass the type as dictionary, and we'll pass the message here, and message will be like annotated into that list only. Annotated, we'll pass this into list, and we'll add message here, so it will be annotated at each step. So the list is small, that's why we are getting error here. Let's execute it again. It is executed now. So now into this, we'll first actually import our .env. So for this LLM, I'm using OpenAI API key, and I'm using one tool called also Tably search I'm using. You can use your keys. I'm just importing this here from .env, import .env, and I'll call this also .env. Let's execute this also. I need to basically install this. Let's go to terminal. Type to let's restart our kernel. Now we will look the .env. So in .env, basically I chat GPT OpenAI API key, and I have Tably search API key also. Tably search you'll get for free, but OpenAI API key you need to pay. Let's import the .env, and let's load the .env here. Let's execute it. We need one more marker set. So here basically we'll add the brain of our application, that is LLM itself. So I'll use the GPT-4 model of OpenAI here. I need to import first chat OpenAI. From LangChain OpenAI, import chat OpenAI, and from LangChain dot chat models, import chat init model, and I'll call this variable as LLM equal to chat OpenAI model. I'll use the GPT-4. Let's execute this. That's perfectly fine. Now in the next cell, I'll reinitialize it. This is slightly older LangChain utility in a chat model, but it works similarly. So I'll reinitialize it like init chat models. I'll pass the model equal to GPT-4, and I'll display LLM. I'm getting error config has been set, but no fields is configurable. Let's shift the error into. Okay, here I have to pass the OpenAI. This model is from OpenAI equal to not equal to basically we pass here. So here we are getting on this GPT-4 model. It is initialized perfectly. Output so that it is configured. Now I'll define one method here for our chatbot. So our first node function for the graph will be chatbot. So I'll define here chatbot, and I'll pass the state here. State I've already explained, it is very important for any chatbot. It contains the present state of that node, and I'll return the message dot invoke, and I'll pass the state here. Instead I'll pass the messages to is closed perfectly fine. Let's execute it. State is not defined, it is telling define the state. Yeah, this is initialized now. In the next cell, we'll build the basic graph. So I'll use the graph builder here. Graph builder is basically we create the instance of the state graph here. We'll tell our user to state class for managing the data. So I need a graph builder first, and graph builder is state graph that we have imported from LangChain, and I'll pass the current state here. I'll add the node here, LLM node first. In the graph builder, I'll add node, and I'll call this node as LLM chat. I'll add the edges also here. So we'll have the start node, we'll have the end node, we'll have the LLM chatbot node, and in between there will be edges that will basically contain the transaction between start to LLM. So I'll add the entry point here, graph builder bot. So this will be our entry point of our chatbot basically. And now I need to add the end of this end node for this graph builder dot add edge, and this will be from start to end. LLM chatbot from start till end, and we have already imported from LangGraph. Now let's compile the graph. So graph is equal to graph. Let's run this. Okay, I need to write it into the code cell. This is executed. Now let's display this graph first so that we can understand how it is. For that display, I need to import image display here from ipython dot display import image display. And let's try to display image equal to graph dot png. No, I need a mermaid graph here. Display image I'll call the graph here. Graph, we have get graph in drama.png, that's fine. And let's find the exception also here. Exception, we'll pass the exception. We'll just pass it, let's execute it. So here is the basic display of our chatbot. We'll have the start node, we'll have the LLM chatbot, and we have the end node. Now let's actually run our basic chatbot in a new code cell. So we'll try to invoke this graph. I'll pass the message response equal to, I'll store the message into response graph.invoke, and I'll pass the message. You are getting the suggestion also here, you can pass that also. I'll just pass the hi message equal to, I just want to pass hi here, message is hi. Let's execute it. It's not closed properly. I need to close this one here. Curly braces. During task with the chatbot and ID, we are getting messages. I think spelling is not correct something. Now let's actually run our basic chatbot in a new code cell. We have typed this hi, how are you? Here we are using graph.invoke method, passing our initial state and as a dictionary with the user's first message, hi, how are you? So this is now we access the message list from the response, what we have invoked, and we get the -1 element of this message here. So we are getting the LLM response here, and there you have it, a basic chatbot basically successfully responding to our greetings, uh, simply, but yeah, it's working. So for a better user experience, especially with a longer LLM response, we often need to stream the output. Let's modify and stream the output. I've already written this methods, written this code. You can write it on your own. Let's modify how we invoke the graph to enable streaming. So graph.stream, we are passing stream here, and this method yields intermediate events as the graph executes, allowing us to process the data as it's become available. For any real-time application, we use this. So we are getting the response here, LLM chatbot. Now I'm trying to create one tool here. So that tool I'll pass to our LLM, and it will be built in with our LLM, so that our LLM can decide whether to use the LLM chatbot or whether to use the tool. So this is a Tably search tool. This is for searching the content on web. You can get any other tool also, but Tably search is free, so I've utilized this one. We are invoking this, what is the LangGraph method here. Let's execute it. It is searching, and we are basically getting two searches here. We are passing max result equal to 2. Let's try to pass it as 3. So basically it will do the 3 searches. We are getting the 3 responses here. One is from IBM, one is from Geeks for Geeks, third is from Medium, and we are getting the content here. You can print out this content also. We are now again creating one more tool, that is a multiplication tool. We are passing to A and B here, and we are returning just simply A cross B. And now we are creating this tools variable, and we are passing into this tools our first tool, Tably search tool, and second tool, that is a multiply tool. Let's execute this also. Let's execute this also. And now in the LLM with tool, so LLM with tool was already variable here where we passed our LLM. Now we'll bind the tools here. So let's bind it out. Here we take our LLM, basically LLM dot bind tool method. So passing our list of tools into our LLM. This creates a new LLM runnable LLM with tool, and that's now basically LLM with tool is tool aware. So when we call this LLM, it will not just generate the plain text, it can also output a special tool call messages if it determines whether tool is needed. So let's suppose we are searching anything for recent data. it will call to tably search. If we are, let's suppose, asking any multiplication related task, so it will call the multiply tool. Let's print it out. If you'll go to this object, you'll get that it has the multiply and tably search tool also. You can get it. Uh, Now we are basically creating two method. One is tool route method, one is tool node method. In tool route method, basically we'll decide whether to call the tool or whether to call the LLM chatbot. So LLM will decide whether tool is needed or LLM chatbot is needed. And then we have one tool node method. In this, basically we'll decide whether multiplication tool is needed or table search tool is needed. Let's execute it. Now we are creating one graph here. In this graph, we have already created that graph above also. Basically, we just have created here one more node, that is a tool node here. So we have a start node, that is LLM chatbot. Then we have a start node, LLM chatbot. Then we have one tool node. If a tool is needed, then it will go to tool node. If not, it will again go to this end node. And if tool node is not needed, then from LLM it will go to end node. And we have added one conditional edge here. So in this conditional edge, we have passed the tool route and tool LLM chatbot. So with this, basically it will again from tool, again it will go to LLM chatbot. Let's execute it. I'll print it out, this graph here. I've already printed out here. So now you can see from start it is going to LLM chatbot. If tool is needed, it is going to tool node. And again it is giving response to LLM chatbot. From there it will go to end. Let's utilize this. Let's check how it is using this tool. We are giving our user message here, what is 12 multiplied by 5, and we are getting the response as 60 here. Now let's search what is the capital of France here, and we are getting the capital of France is Paris. So now our LLM is basically aware of these tools and it is utilizing these tools. Now our agent can use tool. So now we are again starting one more new topic. So we are actually trying to give a memory to our LLM so that LLM can basically remember the past information also. So now we are giving this message in to our LLM, our chatbot, that give me the recent AI news and then multiply 5 by 10. So how it will execute? It will give this message to LLM chatbot, give me the recent AI news and multiply 5 by 10. So recent AI news will basically will call to this tool and it will get the recent AI news from Tably search. It will again come to LLM chatbot and it will perform the second operation 5 by 10. It will again call to the second tool, that is a multiply tool. It will get the response and that will get it will go to end node. So let's run this. We are getting the recent AI news and now we are getting the 5 multiplies by 10. Answer is 50 here. So it is performing like this. Now we'll basically touch one more topic, that is giving a memory to our chatbot. How we are giving memory to our graph-based chatbot here. So let's suppose I'm giving my name here to chatbot. Hello, my name is Kush. So it is replying like, hello Kush, how can I help assist you today? Now again I'm asking what is my memory. So it will not be able to recall my memory because there is no memories that we have given to our chatbot. So I'm sorry, but I can't determine your name based solely on the interaction. Now into this we'll basically just pass our memory saver here and it will basically save the memory. This complete graph is same like before. We have just passed the memory saver here. Let's try to execute it. Can't include node tool node from the LangGraph. Let's restart the kernel. Let's execute it again from so now we are done with tool calling of our LLM chatbot. Now we'll basically give a memory to our tool bot. So currently our chatbot is not able to remind the past conversation. Let's suppose I'm giving my name to our chatbot. So it is replying, hello, Kus, how can I assist you today? Now I'm again asking what is my name. So it will not be able to recall the name. I'm unable to know your name unless you share it with me because we don't have any memory here. So now I'm passing the memory saver here so that our chatbot is able to remind the past conversation into this. Chatbot is completely same what we have created before. We just pass the memory saver here. Let me display the chatbot here. It is completely same here. And now we are passing into this config. We are passing the thread ID as one, and I'm giving my name is Kus. So here it is giving the response, hello Kus, how can I assist you today? Now let's recall this. So it is giving, hi, my name is Kus, how can I assist you? Now again I'm asking what is my name. So it is replying me, hello, your name is Kus, how can I assist you today? So now it is able to basically access the past memory, past conversation memory here. Yes, your name is Kus. What can I do for you today? So it is able to recall. Now we'll go to one more topic in streaming. So basically in streaming we have two methods. One is sync method and one is async method. Let's create this graph here and I'm giving this message. My name is Kush and I like cricket here. So it is able to recall this. Hello, my name is Kush and I like cricket. This is human message and this is AI message. In streaming basically we have stream type and a stream type and additional parameters in this we have values and update. So values will basically it will return the full state of the graph, like each message will be appended, and in updates only the last state will be appended into here and will only get the last state. So let's suppose we are giving thread id 3 and I'm giving hello, my name is Kush and I like cricket, and I'm giving the stream mode as update. So it will just return the current state. It is giving the AI message, hi, it's nice that it's great to meet someone who enjoys cricket. Do you play cricket? It is giving the AI message here. Now again I'm passing the same method message here and I'm passing the stream mode as values. So values will basically return the first one metadata also and second metadata also. So it will return the human message first and again it will return the AI message append it. So it will return the complete full state here. And let's take one more example here. We are passing here thread ID, new thread ID here. It is a AI message and in values we are passing I also like football. So it will like append to previous conversation. Hello, my name is Kush. I like cricket, and into this it will append this. I like football also. So we'll get the AI message like this only. And then we have a stream method. So in our stream method, basically it will return complete stream here. So all the events will get it here. Thank you. I hope you got a little idea about the LangGraph. And basically we have covered LangGraph, basic graph creation and basic chatbot creation. Then we have created two tools and binded those tools with our chatbot. And then we have covered basically giving a memory to our chatbot. And then we have covered what is the streaming method, what is the stream method, and a stream method. And we covered what is the parameters that we pass it here, like what is values, what is update. So we have covered very few details about LangGraph yet. We'll create one more video. In that way, we'll basically cover human in the loop and then we will go into the debugging part using the LangSmith. Thanks for now. Thank you so much. Bye.